All right, second half of section 9.3. One of the things that you looked at on the video that was posted was expected value. Expected value is sort of the average outcome that you would expect over a large number of trials of an experiment. And so what you do is you take the probability of each outcome and you multiply it by the value of each outcome. So all of these A sub 1, A sub 2, those are values. So a real quick example, easy example to think about is those dice that we were just talking about. So if you roll a die, you can talk about the value of the sum of the die, right? So it rolls and you get a 7. So that's the value. Or it rolls and you get a 12. That's the value. And then the P is the probability of that roll happening, okay? So the example that we're going to look at is number 6. We're going to do a lottery. So a lot of the things in this chapter, in this section specifically, even of the chapter, are gaming based, right? In fact, a lot of them in the chapter we've done some cards and stuff too, but they're gaming based specifically. And so this one's looking at a lottery. In a given lottery, we know that the odds of winning the lottery are 53 million to 1. 55 million to 1, if I could read right. 55 million to 1. What is the probability of winning the lottery? So remember, odds and probability are slightly different. What do I have to do to find the probability if I'm given the odds? Okay, it's going to be a fraction. What would go on top, Kate?
Well, the 1.
The 1, good.
There's just one win.
There's one win.
Total amount?
The total amount. So what is the total amount if the odds are 55 million to 1?
Would it be 55 million?
It's close.
54.
The other direction, Lauren. 55 million 1. Yeah, okay, so let's just pause and make sure that we remember how these work because we have two directions that we can go, right? So if we're given odds, this 1 would be the person who wins, and this 55 million would be the ones who lose, which means the total number who play, who've gotten a ticket or whatever, is the 55 million 1. It's the two added together. Okay, makes sense? Excellent. All right, so we're going to do the expected value of this now. It says the grand prize is 14 million, and it tells us that a ticket costs $5. Okay, so it asks if the game is fair. The game is fair, remember, when the expected value is 0. So we have to figure out what the expected value is, and then we can make the decision based on that outcome, whether it's fair or whether it's not fair. And we can also even decide who it's unfair to if it's unfair. It's unfair to the person who plays, or it's unfair to the person running the lottery. All right, so we have two options when we play the lottery in this particular setup. What are they? Winning or losing. Those are our options, right? Okay, so what do you win when you win? Money is correct. Yes. What? $14 million, but not exactly. Minus 5, because you paid $5 to play. Okay, so I'm going to write down first what you guys just said. So we have our value of winning. So I'm going to put V of winning times the probability of winning. We'll fill those numbers in a minute. And we're going to talk about the value of losing and the probability of losing. Okay, so we've already said that if we win 14 million. I'm going to actually write it in exactly the way you guys just said, minus 5. So it's really 13,999,995, which we'll put in a second. What's the probability that we win? Yeah, part A, right? Part A. So we have 1 out of 55 million. 1. And then we're adding to that. What's the value if we lose? Negative 5. Why? You lose the cost of your ticket, right? I mean, if you only bought one ticket. Anyway, that's the way this problem's set up. So it's negative 5. It's the cost that you paid to play and did not recoup. What's the probability that you lose?
Is it gonna be the probability of winning the workers, like, the,
Well, if you're saying, is it going to be the flip of the fraction, that answer is no.
okay. Is one still on the top? Or no?
No.
It would be the 55 million.
Okay, so 55 million people lose, right? So that's how many, losers there are. It sounds funny, but yeah, a lot of people lost. What do I divide by?
The grand.
Yeah, the grand total, the 55 million won. Yeah, exactly. I mean, this is a number really close to the number 1, right? 55 million divided by 55 million. Well, it's very close to the number 1. You will need your calculator, so grab that if you didn't already get it out. And if you wish, we can actually rewrite this first piece over here as its value. It's 13,999,995. I'm going to use that number to calculate with instead. What'd you get?
The whole thing?
Mm-hmm. After all of it, what'd you get? Okay, I've had eye contact with one person, so I think one person's found their answer from the calculator. All right, a few of you have looked up. There's some puzzled looks. What did we get? Somebody tell me some numbers you get.
-4.745 would be.
Like that? Okay. What'd you get, Addie? Not that?
No.
Okay. What'd you get? Lauren got that? Kate?
I got that.
Okay.
I got it on my phone. So.
Okay, yeah, that's fine. All right, so we might want to check your work in a little bit, Addie, but yeah, this is what we should get. We should get negative 4.75 approximately. Yeah, so is it a fair game? No. So we can talk about what it means in a minute, but this is not equal to 0, so it's not a fair game. Now, as we're looking at this whole problem, we were looking at it from the perspective of the person playing the game, right? What they won or what they didn't win. So the negative here is a bad thing for the person playing the game. It means that on average, when they play this game 55 million times, they come up with an average loss of every game of negative $4.75, give or take. They've lost $4.75 every time. Okay, that's what it really means. If the number had been positive, like let's say that the number came back out and here it said 1.07, that'd be positive, right? And so it would mean that you would actually be winning on average $1 every time you played the game. Okay, so think about another game. The lottery doesn't make sense for this particular context, but think about another game. All right. This is what happens, though, with many state lotteries. They like to say that the proceeds benefit education. Nod your head if you've heard that before. There's a reason they say that, and it's actually sort of kind of true, so we'll talk about that later. That's not the point of the question, so let's finish the question. But under these conditions, if all proceeds benefit education and 1 million tickets are sold, what is the expected value of the lottery sales? So what that's saying is that the lottery wins on average $4.75 from every ticket, right? The person loses $4.75 for every ticket. The lottery gains $4.75 for every ticket. And this is saying that they sell 1 million tickets. So how much money is this if we multiply this out?
4.75 million.
Yeah, it's 4.75 million or 4,750,000. Okay, so they're going to have an additional 4.7 million. That's not really the way it works with a lottery. Either somebody hits the jackpot or they don't, correct? Which means that this averaging business is not really what's going to happen unless you have it enough times that on average there's a number of wins versus the number of losses and it all works out. So what really happens, what are the possibilities? Well, one possibility is no one wins. No one wins the lottery, which means that they each had $5 tickets, not $4.75, and there were 1 million of them. Which means education or the state or whatever actually made $5 million. That's one option. Option number 2 is that someone did win. By the way, it's perfectly fine for us to say someone wins. If multiple people win the lottery, they split the jackpot. That's the way it works. So the payout's the same either way. It's not like 5 people won and now they each get $14 million. That's not what's happening. It's one payout of $14 million if that happened, okay? So if someone wins, there still were only $5 million paid, right? $5 tickets, 1 million tickets paid into the system, right? Were paid to the state. But then they have to pay out how much to the winner? 14 million to the winner. So this looks suspiciously like a negative number, does it not? We have 5 million minus 14 million. What does that give me? It is negative $9 million. So we can look at averages all we want, but these are the real 2 outcomes that can occur. Now, what does the state really do? Well, they offer payouts that aren't the full amount, right? You only get this payout amount if you take it over the course of like the next 30 years or something like that. Or they'll offer you a partial payment in a lump sum. So they'll be like, you won 14 million, but if you take it now, we'll give you 4. Right, or something like that. So they make deals that are like that, and it's set up that way. It's in the fine print of all of it. So it's not a deceptive thing. It's just that's how they're run. Okay. All right.